Hello everyone, and this is Ganesh, and in this video I am going to explain about remainder theorem of polynomials. That means in polynomials what is the use of remainder theorem, and by using remainder theorem how can we find the remainder without doing actual division. So I am going to explain a few examples. Easily you can understand how to use remainder theorem. Okay, first I'll explain one example. Generally, the given polynomial x cube minus 2x square minus 5x plus 4 is dividing with x minus 2. So, in this long division method, we are going to find a remainder. What will be the remainder we'll see. After that, by using remainder theorem, I'll find the remainder. Then compare how much easy using remainder theorem. Let us see how can we find it by long division method. First, to find the first term of coefficient, first we have to divide first term of dividend x cube by first term of divisor x. So what will be the answer? It is x square. So x square, immediately write it as a quotient, and this x square multiply with again divisor will get x cube minus 2x square. This expression write it under the dividend, that is x cube minus 2x square 2x square. Yes, if we subtract these two, signs will be changed, minus, and it becomes plus. Then these two gets cancelled. At the same time this is plus 2x square plus minus 2x square again cancel. Then one more time is there, for minus 5x bring down, and at the same time we can bring down 4 also, because 2 terms we are getting, that's the reason 4 also bringing down, there is no problem. Now again to get the second term of coefficient, again minus 5x is divides with x, then we'll get minus 5, that minus 5 write it here, then again 5 into x minus 2 multiply, you will get minus 5x plus 5 to the 10. So this you have to write it here, 5x plus 10, and here 5x plus 10 means this minus 5x. Yes, now subtract it, plus and minus, signs will change, these two gets cancelled, and 4 minus 10 is minus 6. So minus 6 is the remainder. Generally if we to find remainder, if we follow the long division method, so minus 6, this is the procedure we have to follow. Now I'll explain remainder theorem. If we use remainder theorem, can we get minus 6 or not? Let us see. According to remainder theorem, what we have to do, generally the dividend, what is the divisor is there, the divisor for x minus 2, we have to find the 0 of x minus 2. To find 0 of x minus 2, I told you already, x minus 2 equal to 0, then x equal to 2. X value we got it, that means 2 is the 0 of x minus 2. Now this x value we have to substitute in the given dividend. So the dividend, for example, if I take that is p of x is equal to the given polynomial. Then in the place of x, I will substitute 2. P of 2 we have to find it. Then first x cube means 2 cube minus 2 into 2 square minus 5 into 2 plus 4. Substitute all the value in all the terms, x value 2. Now 2 cube is 8, 2 into 2 into 2. Then 2 to the 4, 4 to the 8 again, and 5 to the 10 minus 10 plus 4 is there. Here plus 8 minus 8 gets cancelled, and minus 10 plus 4 is minus 6. See, minus 6 is the remainder. So in this, here also in the division method also we got minus 6 is a remainder, and here also if we do in this way, here also we are getting minus 6. So this is called remainder theorem. Now I'll give you the definition of remainder theorem. If p of x, if p of x is any polynomial, given polynomial, and it is dividing with x minus a linear polynomial, if it is this p of x polynomial divide with x minus a another polynomial, and this must be linear polynomial, the power is degree of this linear polynomial is 1. So then what happen, then the remainder is when we divide p of x with x minus a, the remainder will get p of a. So this is a remainder theorem. Then here p of x polynomial degree is it's not greater than or equal to 1. It's not greater, that means polynomial of degree yes, here generally two conditions you have to remember. Here p of x, that is a polynomial, the degree is always greater than or equal to 1. Greater than or equal to 1, it should not be 0. The degree of this p of x should not be 0 or less than 1. That should be 1 or greater than 1. And this must be, that means the divisor x minus a, that polynomial must be linear polynomial. Then the remainder is p of a, that means whatever the 0 of this polynomial, that we have to substitute in the given polynomial. This is the general definition of remainder. And here is another example. If p of x, it's a polynomial and the degree is 3, and this is if this p of x is divides with x minus 1 by 2, then find the remainder. And at this time we no need to do that long division method. Even it is fraction, long division method is very difficult to find either quotient or remainder. So for these kind of things, remainder theorem is very useful. Then how can we find it? Let us see. First, x minus 1 by 2, x value we have to find it here. I told you x minus 1 by 2 is equal to 0, then x equal to 1 by 2. This x value we have to substitute here in the given polynomial, that means p of 1 by 2. Then 1 by 2 whole cube plus 3 1 by 2 whole square plus 3 1 by 2 plus 1. Substitute all the values. Then we'll get 1 by 8 plus here 3 by 4 plus 3 by 2 plus 1. So these all are fractions. If we find, if we add all these fractions, we'll get that answer. And for adding all these fractions, what is the LCM of all these things? Means 8 is the LCM. Then here it will be 1, and here 2 3s are 6, and here 4 3s are 12, and here 8. So after that, if we add all these numbers, if we add all these things, it is 27 by 8. So this is the remainder if we divide the given polynomial with x minus 1 by 2. So this is the use of remainder theorem. Just listen the problem here. If the polynomials p of x and q of x, two polynomials, are divided by x plus 2, both are divided by x plus 2, then they are leaving same remainder. That means what? If p of x is divided by x plus 2 or q of x is divided by x plus 2, then both are having same remainder. Then find a value. So in this problem, here a is there, here also a is there. This a value we have to find it. So they said in the given question, they said both are leaving same remainder. So remainders are equal. So if we equate the remainders, we'll get that answer. We'll get the we can find that a value. So how can we find remainder? By using remainder theorem, it's easy. For example, x plus 2 is a linear polynomial. Then what is x? X is equal to minus 2. I told you x plus 2 is equal to 0, then x equal to minus 2. So this x value, substitute in both the equation. Then what happen here? P of minus 2 equal to this will get. That means p of minus 2, what will happen? P of minus 2 is equal to minus 2 whole square plus a minus 2 square, here 3, sorry, plus 5. And if q of minus 2, if we take, q of minus 2 is minus 2 whole cube minus 2 square plus a. These two equations here. That means this is the remainder of q of x, This is p of minus 2 is the remainder of first p of x polynomial. So if we equate these two, that means reminders, they said same reminders, that means this one and this one both are equal or not, equated. So if I equate minus 2 whole cube, that means here I am writing p of minus 2 plus a minus 2 whole square plus 5 is equal to minus 2 whole cube minus 2 of minus 2 square plus a. So these two, this is the remainder of p of x and this is the remainder of q of x. So these two are equal in the problem only given. Then if we simplify this, a value we can find it, minus 2 whole cube is minus 8 and here 4a we are getting plus 5, that equal to here minus 8 again, and here also minus 2 means 4, 4 means 2 4s are 8, minus 8 again plus a. Then you see here minus 8 both gets cancelled and finally 4a is there, 4a. If I send this a this side, minus a and minus 8 minus 5, then 4a minus a is 3a, that equal to minus 13 minus 13, that implies a is equal to minus 13 by 3. So minus 13 by 3 is the value of a. So in this way we can find a few kind of problems they are asking using a remainder theorem. Yes, I hope you understand well and you I think you don't have any doubts about remainder theorem. If you have any doubts or if you want to give any suggestions, you can leave any comments in the comment box, and thank you very much. Please share it and subscribe.